Another day, another story. The sand replacement method is a widely used technique for the determination of in-situ density of soils. It is a simple and practical method that provides a relatively accurate estimate of the density of the soil at the location where the test is conducted. Here are the steps involved in the sand replacement method. 1. Equipment preparation. Sand pouring cylinder, a metal cylinder with a known volume and a conical funnel at one end. Calibration container, a container with a known volume used for calibrating the sand pouring cylinder. Balance, a sensitive balance to measure the mass of the sand. Tools for excavation, shovel, trowel, etc. 2. Calibration of sand pouring cylinder. Fill the calibration container with sand and weigh it accurately. Empty the sand into the sand pouring cylinder while ensuring there are no air voids. Weigh the sand-filled pouring cylinder and record the mass. Repeat the calibration process at least 3 times to obtain an average mass. 3. Field test. Select a representative location for the test and excavate a hole or a pit. Clean the sides of the hole to remove loose soil and debris. Place the sand pouring cylinder vertically in the hole and embed it firmly. Measure the initial mass of the cylinder and record it. Open the shutter at the bottom of the cylinder to allow the sand to fill the hole. Close the shutter when the sand stops flowing and measure the final mass of the cylinder. Calculate the mass of the sand used, final mass, initial mass. Remove the sand pouring cylinder from the hole. 4. Calculation of in-situ density. Determine the bulk density of the sand using the average mass obtained during calibration. Calculate the volume of the hole using the known volume of the sand pouring cylinder. Divide the mass of the sand used by the volume of the hole to obtain the dry density. Adjust the dry density for moisture content if necessary to obtain the in-situ density. It's important to note that the sand replacement method provides a measure of the in-situ dry density, which can then be used to calculate other soil properties such as compaction, void ratio, and degree of compaction. Additionally, the accuracy of the results depends on factors like the compaction energy, particle size distribution, and moisture content of the soil.